Hello everyone, welcome to today's class. In this lecture we'll discuss about the properties of determinant, which is one of the most important topic of this chapter. Okay, so let's look at the properties and how to apply them to find the determinants easily. Okay, first property. One second. First property. The property says that the value of determinant remains unchanged if the rows and columns are interchanged. What happens when you interchange rows and column? It becomes transpose. So suppose your matrix is A. Okay. Let's say A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. If you interchange the rows and column, it becomes A transpose AT. That means it's a matrix, na? So square bracket. Then it becomes A1, A2, A3. Row become columns B1, B2, B3, C1, C2, C3. Okay. The property says that the determinant of both this matrix as well as this matrix, they are equal. Basically, determinant of A is same as determinant of A transpose. Okay, that's the overall conclusion of the first property. Why that happens is because you have the freedom to open the determinant about any row or column. So suppose you are opening here about first row, so positive, negative, positive. Here you are opening about first column, positive, negative, positive. Just I'm writing first expression. A1 will be multiplied with, leave the first row, first column. Okay, so that will be B2, B3, C2, C3. Okay, determinant of that. Here also, suppose you do that, A1 into, leave the row and the column. Interestingly, you will get the same B2, B3, B2, C2. Sorry, I've written here wrong. Here you will have B2, C2, B3, C3. Okay, slightly looking different, but let's see. If we open this, what do we get? B2, C3 minus B3, C2. Here we'll get A1 into B2, C3 minus B3, C2. So just the first expansion of the determinant gives this idea. Same thing you can do with the other one also, A2 and A3. Same thing you can do here also, A2 into something, A3 into something, like that. But the point is, after opening the whole expression, they will all come same. So the point is that whether you take transpose of a matrix, the determinant remains unchanged. Okay, that's the final conclusion of this property. This is what you should remember. All right, first property done. Okay. Let's take another property, property number 2. Okay. The property number 2 says that I'll take the same matrix, A matrix, as A1, A2, A3, A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay, that's your matrix A. Suppose you have a B matrix and you interchange, let's say, any row or column. He is saying, na? So let's interchange the column. Let's say we interchange these two. Okay, so now you'll have A2, B2, C2 first, then A1, B1, C1, then A3, B3, C3. Okay, I've changed only one column. I've changed one pair of column. Okay, so 2 columns are being changed here. Okay, let's say determinant of this matrix A, some value, let's say determinant of A was coming 10. Okay, so I can say that determinant of B matrix, since only two rows or two columns are being interchanged here, so I can say you will have to get the same answer. It's just that because of changing the rows and column, the sign of the determinant changes. That means for every single change you will get a negative sign. Okay, right now there is one change, so you will get plus 10. The plus 10 will become minus 10. If the determinant of this A matrix was 10, determinant of B was minus 10. Let's say you have another matrix C. Okay, again I'm doing one more change. I'm interchanging these two. Okay, okay, they are applicable to both the columns as well as row. Okay. So now A2, B2, C2, A3, B3, C3, and finally your A1, B1, C1. Okay, so since you have changed the column one more time, two columns are again changed, so determinant of C will become again negative of negative 10. Every time you change a pair of column, the sign of the determinant will change, so it will become plus 10. Okay, or suppose you directly did some sort of transformation, and what is happening here, first of all A1 is getting to the last. Okay, but A3 is not in the first column, it's in the second. That means in order to transform A matrix to C matrix, I have to do two interchange, first row 1 with row 2, then row 2 with column 1 with column 2, then column 2 with column 3. So two changes are there. So whenever you have two changes, so determinant remains unchanged, the sign of determinant remains unchanged. Okay, that's the overall point. If you have even number of changes, determinants remain unchanged. If you have odd number of changes, this is one change. Okay, from A to B, this is only single change of columns. So you, in that case, you have single change, so a single negative sign. Two changes, two negative sign means positive, so effectively no change. Okay, we'll see that in the illustrations when it comes. Modify accordingly. Yeah. Here's a direct property. Next property is very I'll say important, and it's very easy to comprehend also. The property says if you have any two rows of or columns of a determinant identical, means same. Okay, the determinant is 0. That means you don't even have to solve, you can directly say the determinant is 0. Okay, I'll take one question. You tell me the answer for this. If I see this, but the first thing I see 3 2 3 3 2 3. Okay, two rows are same. If two rows are same, I don't have to solve the determinant. I'll say delta is equal to 0. Okay, or two column, doesn't matter, as long as they are identical, delta is 0. Determinant we don't have to solve. Okay. Next property. Force property. The force property says that if each element of a row or column of a determinant is multiplied by a constant, then the value of determinants gets multiplied by k. I'll explain what does that mean. Again, let's take, you have A matrix, A1, A2, A3, B1, B2, B3, C1, C2, C3. Okay. Let's say the determinant is some sort of delta. Okay. And then you have another matrix B, in which first row is KA1, KA2, KA3, B1, B2, B3, C1, C2, C3. Okay. This is the matrix. Okay. Let's put it determinant directly. That was the matrix whose determinant was delta. Now for this, the property says if any row is multiplied by a factor k, your determinant gets multiplied by delta. Okay. Means if this determinant was, let's say 10, this was k times 10. Okay. Whatever that k may be. We'll not use it like this, although. How do we really use this? Okay. We tend to use it like this: KA1, KA2, KA3, B1, B2, B3, C1, C2, C3. If any row or column is multiplied by some k, what you can do is take k common and solve the remaining determinant: A1, A2, A3, B1, B2, B3, C1, C2, C3. This is how we are actually going to use it. Okay. If any row has any factor that is common, we can take it outside the determinant, but it has to be along the whole row or along the whole column. Okay. This is how we are actually going to use it. We can take k outside from one row. All right. Finally, the last prop. Let's use this property first. Let's take one example. This is a question. You have to evaluate this determinant. Okay. Now the moment I see this, I see big numbers: 102, 18, this. Rest are still smaller. Now if you look at 18 and 36, they are multiple of 6. And interestingly, I think this one is also a multiple of 6. 1, 42, 6. Yes, this is also multiple of 6. So I can rewrite this as 6 into 1 and 7, 17. That is 6 into 3, that is 6 into 6. 1, 3, 4, 17, 3, 6. Okay. Now the factor of 6 is common from first row. I can take it outside. Okay. That was your k, na? This time your k is 6. So any row being multiplied by any factor, I can take it outside. So 17, 3, 6, 1, 3, 4, 17, 3, 6. Okay. Two rows are identical. Determinant is 0. So 6 into 0, directly 0. Okay. All right. Now last property, and I'll have to say like the best property, because no, this is not the last. There's one more. The last property actually is the best property because 99% question of determinants are solved by that. Okay. This one says if some or all elements of a row and column are expressed as sum of 2 or more terms, then the determinants can be expressed as sum of 2 or more determinants. Let's see, what does that mean? Language sometimes makes it typical. So let's see with the help of an example, what does it really mean? So let's say you have row 1 has a1 plus lambda, a2 plus lambda 2, a3 plus lambda 3. So we can break down in two determinants, one with a1, a2, a3, one with lambda 1, lambda 2, lambda 3, this one. b1, b2, b3, c1, c2, c3 remains same. Means you can break down the determinants in along the your addition, but for a single row. Remember that. It's not like if it was lambda 2 or some mu1, mu2, then we can break it for that also. No, This is for single row. If you have multiple rows in addition and subtraction, then you'll have to first do it for one row, then again do it for some row 2, like that. Okay. All right. This property, I don't think you need to learn it. Just remember this example. Like you can break it from this part. You can break it about the addition. Okay. Again, some use of this property, which is again very direct. Okay. You have to, although they're saying show that, I'll say evaluate. Because the moment I say show that, then you'll think that we already know the answer. Okay. So this is a question. Instead of show that, evaluate. Okay. This time addition is going around this row 2. So I can break down this as A, B, C. A, B, C, X, Y, Z, Z. Then you write another determinant with row 1 and row 3 same, A, B, C, X, Y, Z, and this time you write 2x, 2y, 2z. Okay, that is about breaking this determinant in two parts about this addition. So 2x, 2y, 2z. Okay, 2 is common. I can take it outside. Okay, and you can also see these two rows are same. So determinant 0 plus 2 times ABC XYZ XYZ. Again, two rows are same. If two rows are same, the determinant is 0. 0 plus 2 into 0. That's a big 0. Okay. So interestingly, for these kinds of questions, the answers are usually 0. I mean, if you have to really guess answer for any determinant, 0 could be one of the possible answers that you can guess, but it's not always for sure that. Okay. All right. Finally comes the last property, and what I said, the most important, like 99% questions done through that property, you'll see. The property says that, no need to read this, just understand this. What I can really do is, I have a freedom. Suppose we are doing for some determinant. So I have the freedom. I can do one operation. R1 goes to R1 plus K times, let's say R2, R3, or R. I think 3 is there, na? Maximum for you, 3 is there. 3 rows. That's it. This K can be anything. Okay, like I can do R1 plus R2 also. I can do row 1 goes to row 1 minus. We can do subtraction of rows also. We can do R1 minus 2R2 also. R1 plus 3R2 also. It's freedom. You can do anything. It won't affect the value of the determinant. We can change the row. We can transform the row. But remember, this factor will be with R2 only. We are performing it on R1. R1 remains the same. R1 goes to R1 plus some constant into R2 or R3. But if you cannot write like this, what is valid, which is invalid, this is invalid. If I do like this, 2R1 plus 3R2 like this is wrong. The problem is this, I cannot multiply directly R1 with 2. Okay, but I can multiply R2 with 2 and then add it to R1. Okay, same thing you do with the column also. Again, you have the freedom. C2 goes to C2 plus C3, C2 minus C3, anything. You can do it row wise as well as column wise. Complete freedom. Okay. Let me show you one example how this makes again the questions. One second. Okay, yeah, this question. Let's look at this question. Okay. All right. So this is your row 1, row 2, row 3. Now you can see how complicated this is right now. Okay. and the question is evaluate again. Okay. Evaluate. Okay, what I see is these expressions are complicated, so I'll not try to deal with them. Instead, what I'll do is, you can see here a, this is 2a, this is 3a. Okay, so what I can do is, first should I take a common? If I want, I can, but I'll write one operation. You try to see what I'm trying to do. R2 goes to R2 minus 2R1, and R3 also goes to R3 minus 3R1. Two operations I'm writing. The purpose is I want to make them 0. Why I want to make them 0? Because once you have zeros in the determinant, you can solve them very quickly. Okay, because you don't have to really expand, you have to just solve for one element. So that's the target. So nothing happens with the first row, a plus b, a plus b plus c. Now be very careful while doing these operations, because if you make a mistake here, you will not get the simplified answer. So the operation is row 2 goes to 2 times R2 goes to R2 minus 2R1. So this element goes to this minus, I have to multiply this with 2, the whole row, and then subtract correspondingly. 2a minus 2a becomes 0. This multiplied by 2 and then subtract from this. So 3a minus 2a is a, 2b minus b is b. Okay. Then again this needs to be multiplied with 2 and then subtract. So 4a minus 2a is 2a, 3b minus b is b, 2c minus this is also 2c, so that becomes 0. So that's it. Okay. All right, this is done. Now for row 3, again you have to multiply this by 3, each and every element, and then subtract correspondingly. 3a minus 3a becomes 0, 6a minus 3a is 3a, and 3b minus 3b becomes 0, so 3a only. 10a minus 3a, 7a, 6a minus 3b, 3b, 3c minus 3c, 0. So that's it. This is the first transformation that I've done, because if we do this operation, R2 goes to R2 minus 2R1, 3R1, it won't affect the value of determinant, so I've used this. Now the benefit was, because now opening about this column will be very simple. A multiplied by, I have to solve this only. What I can do is, actually I can directly cancel it and make it 0 if I want. Okay. Should I? Let's open it. Okay. Expanding about C1. Okay. One second, this is value wrong. This value is wrong. Because when we multiplied by this, because if we are getting this 3a, this should have been 2a. Okay. 3a minus 2a, 2b minus 2b it was supposed to be. I made a mistake. This element was supposed to be 0. Okay. Yeah, now it is looking quite symmetrical. 3a minus 2a is a. So a, 3a, 2a plus b, 7a plus 3b. Okay. Rather than now expanding, now I have one short way rather than expanding. What I can do, I can still generate more zeros. Yes, one option is directly multiplying them and solve it. Of course, that can be done. But I'm showing you one more step which even makes the determinant even more simpler. I can still get this as 0. Why? Because if I multiply this by 3 and then subtract it from row 3, I will get a 0. So in order to expand the determinant using properties, you try to generate as many zeros as possible. Okay, a plus b, a, b, c. this is a, this is 2a plus b, and the operation is r3 goes to r3 minus 3r2. So I have to multiply this with 3, this whole thing with 3, and then subtract. Okay, so let's do it. So 3a minus 3a becomes 0. That was the whole target. 7a minus 6a, that will become a. 3b minus, this is also 3b, that becomes 0. So a. Okay. Now look at this. If I expand now, expand about C1, so that will be positive, negative, positive. Okay. Although we don't need that. So positive a into determinant of, leave the row, leave the column, solve this. So a into a square minus 0 into anything is 0. So that's the whole purpose we created this another 0. So a into a square. Okay. So the answer was very simple, a cube. Okay, that's done. Okay. All right. Look at this determinant. Again, one more application. I mean, one more question. Applications are like a lot for this. The ideas are too much varying, okay, but mostly we'll be using these kinds of ideas. So don't try to solve the questions in one go. First understand how these illustrations are working, what are the possible options, what you have to look forward. Okay, if I see this question and I have to calculate this, okay, what I see is 1 1 1. That's a good thing, because ones help a lot, because I can create there 0, there also a 0 by subtracting. But before that, let's look at this. X and y is present, z is here, y, z, x is here, z, x, y is here. If only z was here, x was here, y was here, they will be all alike. Okay, so what I'm going to do is perform one operation. R1 goes to R1 plus R2. Let's add row 1 and row 2. So your determinant will look like x plus y plus z, x plus y plus z, x plus y plus z. Now why is that helpful? Z, x, y, 1 1 1. We can take common from a row or a column. X plus y plus z is present in every single column here. So x plus y plus z common. Determinant is 1 1 1, z, x, y, 1 1 1. I hope you see where I'm going with this. Two rows same, identical rows. Determinant is 0. 0 into anything is 0. So you don't literally have to solve it, just the correct operation, and that makes it simple. Okay. All right. Now let's look at few questions based on proving 0, and then few questions in which we have to solve it accordingly. Okay. Okay, first question is saying, okay, and also we'll have to do it very fast, so of course we'll be using properties. Expanding is one option, but that is a last resort. Try to use as much property as possible. Okay, this is x plus a, this is x, y plus b, this is z plus c. I think you can understand. This is x and a, this is y and b, this is z and c. If I do c1 goes to c1 plus c2, what is going to happen? C1 will become x plus a, y plus b, z plus c. Okay, a, b, c, let it be, and x plus a, y plus b, z plus c. I think it is very obvious now what we can do. Two rows identical or two columns identical, determinant is 0. Okay, or we could have done it like expanded the into two determinants, x plus a plus x, y x a x y b y z c z, and then another determinant. We can split about this addition also, but I thought of this. Okay, so there is no single way to solve this. There can be multiple ways to solve a question. Let's see the next. A minus b, b minus c, c minus a, b minus c, c minus a, a minus b, c minus a minus b, b minus c. A lot of complication, but you see a symmetry, a b c, then b c a, c a b. Okay. Now, one key hint to solve majority of question again is try to add row or column. You might get something. Okay, try to do this operation. R1 goes to R1 plus R2 plus R3. If you don't get anything, you can try this, or C1 goes to C1 plus C2 plus C3. Just add them along row wise or column wise. Something may or may not happen. Okay, but you can try. Let's see if I add them row wise, what happens. If I add them row wise, A minus B, B minus C, C minus A and A will cancel, B and B will cancel, C and C will cancel. So first element becomes 0. If I add this row 1, row 2, row 3, B and B cancel, A cancel, C cancel, again 0 and another 0. Okay, that's B minus C, C minus A minus B, C minus A minus B, B minus C. The whole row is 0. If we expand along this, if any row is 0, directly we can say the determinant is 0, because if we expand along this, 0 into something, 0 into something, 0 into something, 0. Okay, so if you don't get anything in a determinant, just try to add them and see if you can get anything out of it. This is a one hint. Okay, ever stuck, use this. Finally, some numbers. Okay, 2, 3, 5, 7, 8, 9, fine. 65, 75, 86, very large number. Now, if I want to reduce them, because we can do addition and subtraction, what I can do is subtract them. And why I use this one? Because if I subtract 7, that's better than subtracting 2. Even why subtract just 7? Why don't multiply with something and then subtract? So I want to do C3 goes to C3 minus C2, but I can multiply this C2 with something also. So if I want to get close to 65, I can multiply a C2, this 7 by 9. Okay, let's see what happens. If I do this, so 2, 3, 5, 7, 8, 9. So basically now what you have to do, 65 minus 9 into 7. So I'm multiplying the column with 9. So 63 minus this becomes 2. 75 minus 9 into 8, 72. That's 3. 86 minus 9, 81. 86 minus 81 is 5. The moment I do this, two columns are identical. Again, I don't have to solve. This determinant is 0. Okay. All right. Done. Let's look at another question. Okay. One, good. 1 1 is good. Why? Because we can create zeros if we want. But let's take a look at the whole expression. This is 1 1 1 BC AC or CA or AB, that's AB plus AC. Next is BC plus AB, this is AC plus BC. Okay, if you look at this column 2 and column 3, AB BC is here, AC is here. Okay, similarly AB BC AC is here, AB BC AC is here. Okay, so in each of the term of column 3, if I can add this here, I'll get the same expression. So my operation is C3 goes to C3 plus C2. So 1 1 1 BC AC AB, this becomes AB plus BC plus AC or CA. Second one also becomes AB plus BC plus AC. Third one also becomes AB plus BC plus AC. All the elements are identical, same. Okay, so I can take them common. I can take common from this column 3. So AB plus BC plus AC, if I take common, I get 1 1 1 BC AC AB, and again 1 1 1. Again 2 rows or 2 columns identical, determinant is 0. Nothing need to solve, 0 into anything is 0. Okay. All right. So we have done a lot of questions now based on 0. Let's see a different kind of question in which you don't have to prove it's 0. What they can do is they can write here k and they'll ask find k. So that way they can create a question. And trust me, if they create a question like this, even if you do expand, which you won't be able to do in the exam, you'll not be able to get the k very easily. So you have to use property. Okay, so forget about this too for now. Find k. Okay, let's see. Point is we have to generate A, B, C, P, Q, R, X, Y, Z. Okay, A, B, B, C, A, C addition is there right now. Okay, what did I told you? If you are not getting anywhere, just try to do addition. Okay, AB plus BC, BC plus AC, AC plus this. Let's add them. Row 1 goes to row 1 plus row 2 plus row 3. Okay, let's see what happens. A 2A, B 2B, C 2C. So 2A plus 2 times A plus B plus C. Okay, if I add this also, this will also symmetric, 2 times P plus Q plus R. If I add them vertically, 2 times X plus Y plus Z. Remaining are same, A plus C, A plus B, R plus P, P plus Q, Z plus X, X plus Y. Okay, now 2 factor is common. In the first row, I can take it outside. Okay, so I'm erasing it, not rewriting, and I'm writing it outside. Okay, taken 2 outside. Now let's see. I want A to be here, B to be here. Okay, B and C can be easily generated. How we are going to use this is, so you have to look for the position what is required. See, in the second row, first column, first element, this is B, and right now this is A plus C. Now you have to use the elements above or below to add or subtract to get, you want to make this as B. How can we generate B from the elements above or below? Okay, see, if you subtract these two, okay, these two, A and A will cancel, B, C and C will cancel. All you will be left with is B or not. Okay. So that's the idea. So in order to get B here, I'll subtract. What do I going to subtract? R2 goes to R2 minus R1. Okay. Remember, we are doing operation on R2. I have to write R2 first, and then I can do anything with the row 1 or row 3. Similarly, R3 also, if we subtract, we'll get this element C. So let's try to get these elements. I think correspondingly we'll get the other elements. R3 goes to R3 minus R1. Let's perform these operations. So 2 times A plus B plus C, P plus Q plus R, X plus Y plus Z. If we subtract A plus C, see, A plus C needs to be subtracted with A plus B plus C. So instead of getting B, you will actually get minus B. That's not a problem. At least B is there now only. So minus B. Here you will get minus C. The rest of the expression you don't have to check. They will be symmetric. Here it will be minus Q. Here it will be minus R, minus Y, minus Z. Okay. Alright. Now again, we can take common. Minus 1 we can take common from row 2. Minus 1 we can take common from row 3 also. Okay. So take the negative common. So 2, negative 1, 2 times we have taken common. Rest everything same. A plus B plus C, P plus Q plus R, X plus Y plus Z. B, C, Q, R, Y, Z. Okay. At least now the row 2 and row 3 are matching with the expression B, Q, Y, C, R, Z. Okay. Now in the first position, I want this to become A. How can we get A? By using these elements. If I add them and subtract it from this, I'll get A. So that is going to be my operation. R1 goes to R1 minus R2 plus R3. Add them and then subtract. Okay. So negative, negative, first of all, they cancel 2 times. This will become B plus C will be subtracted from this. So A will be left. Here P will be left. Here X will be left. B, Q, R, sorry, B, Q, Y, C, R, Z. Okay. So we got RK. This is RK. So K is 2 as the answer. Okay. From these questions, you have to understand how the properties work, what is required, how can we simplify accordingly, okay, how to perform the operations. Be very careful with the operations. Okay. All right. Let's take a look at another question. You have to prove this. This is 4a square b square c square. What if the question doesn't give you this and they just ask you to evaluate? Okay. So again, fine, it is given, but just try to think. If I see this determinant, I can see A common in the first row, B common in the second row, C common in the third row. So I can take ABC common. So I get ABC common. What is left? A minus A, BC, A minus BC, and again A, B, and minus C. Again I can take common. A from first column, B from second column, C from third column. So again taking common. So A square, B square, C square is already generated. Now you have the determinant of minus 1, 1, 1, 1, 1, minus 1, 1, 1, minus 1. Okay. You have to solve this now. Of course, we can directly open it. That's one option. But the easiest way to solve any determinant is by generating 0. Let's generate 0 here. Let's generate 0 here. How? By adding this and this 1, we can generate zeros. So my operation is going to be R2 goes to R2 plus R1, R3 also goes to R3 plus R1. I'm going to just add them. Okay. So A square, B square, C square, determinant, minus 1, 1, 1, 0, 0 it will be, adding them, add them, row 2, let's solve, minus 1 plus 1, it becomes 0, 1, 1, we get 2. Then again row 3 will become 1 minus 1 0, 1 1 2, minus 1 1 0. Okay. Now it's better to expand. Expanding about C1. So we are going to expand about this, positive, negative, positive. So A square, B square, C square, minus 1 into determinant of this 0 minus 4. So minus 4. Rest 0 0 we don't have to expand. So basically it becomes 4 A square, B square, C square. So properties with the variable, properties with the numbers also we have applied here. That's your answer. All right. Next is again, the questions are of 2 proof, but these are pretty standard results that you should directly know. Okay. So next upcoming questions, if you can learn it, then only learn it, otherwise no need to emphasize that much. Okay. All right. All right. So again 1 1 1, the moment we see 1 1 1, we know what is going to happen. We are going to create zeros to expand the determinant, because right now it is a square, b square, c square. Addition, subtraction, nothing will work with this. So let's just directly focus on creating zeros here. So the operation will be R2 goes to R2 minus R1, R3 also goes to R3 minus R1. Okay. Now if we do this operation, first row remains same, 1a square. This, let's solve the second row, 0 1 minus 1 0. This becomes b minus a, b square minus a square, b square minus a square. So I'll use the property also, b plus a, b minus a, skipping one step. C for third row, 1 minus 1 0, c minus a, c minus a, c square minus a square will become c plus a, c minus a. Why I use this? Because now we can take common b minus a, b minus a, c minus a, c minus a. We can take common anything from 0, because I can write this as 0, I can write as 0 into b minus a also. No? So I can take anything common from 0. Okay. All right. So I'm taking common b minus a, c minus a. What is left? 1a square, 0 0, 1 1, b minus a, sorry, b plus a, c plus a. Don't emphasize too much, just open it now. Of course we can, you see, suppose you want to use more property, try to generate 0 here by subtracting the operation. R3 goes to R3 minus R2, yes, but I don't think expanding is such a problem here, because it's very simple, multiplication with 1, multiplication with 1. So expanding about C1. So b minus a, c minus a, then determinant while expanding, it will become plus 1 into, so leave the first row, first column, this we have to solve. So c plus a minus b minus a, okay, or minus of b plus a, negative you take common. So b minus a, c minus a, this will become a will cancel, this is c minus b. If we take negative common from this term and this term, we can write them in order. 2 negative common become positive, so a minus b, b minus c, C minus A. I've taken two negatives common, negative negative will cancel. As simple as that. Okay, that's your answer. Actually, it was a two proof question, but still. So 1A A square, 1B B square, 1C C square. These kinds of questions. Directly the result is A minus B, B minus C, C minus A. All right. Let's see the next. Again, you have 1 1 1. It's a good thing, na? 1 1 1. We know what we have to do if we don't have any step. Start with creating zeros. Here also 0, here also 0. C2 goes to C2 minus C1 and C3 goes to C3 minus C1. Let's do it. 1A A cube. That, so let's solve for column 2. So 1 minus 1 0. B minus A. And this is B cube minus A cube. So B cube minus A cube. Use the property of that. B minus A, B square plus A square minus AB. Okay. A cube minus B cube basically. I'm writing that in this reverse. So B minus A, B square plus A square minus AB. Here also, again for column 3, 1 minus 1 0. C minus A, C minus A. C cube minus A cube is C minus A. C square plus A square minus CA or AC, your call. Okay. No benefit, B minus A and 0 I told you, we can take common anything, 0 minus C minus A common. Let's generate those expressions. B minus A outside, C minus A outside. Determinant of 1 A cube, 0 1 0 1. This is B square A square minus AB. This is C square plus A square minus AC. Now if you want, you can directly open the determinant about row 1 and solve accordingly. That will create slight problem. Okay, because the expression this time is complicated. Still, I think that is easy way. So let's deal with that. Okay, expand. Let's expand. About this time R1. So B minus A, C minus A. We are expanding about this row. Okay, so positive, negative, positive, and there is 0, so we don't have to expand about that. So we have to do it for only. We have to do it for only 1. So 1 into. This is 1 into C square plus A square minus AC. Okay, minus this one, B square plus A square minus AB, and this whole will be subtracted. Okay, 1 into this. Okay. All right, so B minus A, C minus A. C square plus A square minus AC minus B square minus A square plus AB. Okay, A square cancels. Okay. B minus A, C minus A, get them copied. Now this is C square minus B square, square, get them together, C square minus B square. This is AB minus AC, so write them AB minus AC. Okay, take two terms at a time and you can see something has happening. You can see properties are being applied. C plus B, C minus B. Here if you take A common, you can write B minus C. Okay, I think something is wrong, slightly, very slightly. What is this? Should have got B minus C, and this is coming C minus B, na? What is the other expression? A plus B plus C. Some plus minus mistake is there. C minus, I have changed the sign also. Should not be there. If only this was C minus B, it is supposed to be C minus B, or something is missing, because B square steps are very less. B square, A square. One second. Should have written the property properly. A cube minus B cube is A minus B, A square plus B square plus AB. So this was a mistake. Okay. Instead of negative, it should have been positive. So just changing the sign. Positive, 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 positive. So here it is positive, and here it will be minus AB. Okay, so I'll rewrite the last of these expressions. Okay, so this will become AC minus AB. Now it's okay. A common, C minus B. Okay, now it's working now. C minus B, C minus B, take common. So B minus A, C minus A, C minus B you have already taken common, C minus B, and inside the bracket you will have C plus B plus A, so A plus B plus C, if I rewrite that. And from these terms, because they are not in order, A minus B, B minus C, if we take two negative common, we can write A minus B, B minus C, C minus A plus B plus C. Okay, by taking two negative common, negative negative cancels. Yeah, so you have to change the property. Okay, I by mistakenly wrote half part of A cube minus B cube and half part of A cube plus B cube. So the algebraic properties are important for solving these kinds of questions. A square minus B square you should know, A cube minus B cube you should know. Mostly these will be used. Okay. All right, now let's look at another kind of problem. Next, both the problems have the same idea now. Next upcoming two problems have the same idea. You look at the expression. First of all, it's very symmetric. X plus 4, 2x, 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 x plus 4, 2x, 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 x plus 4. You have to evaluate this, although the answer is given, but again, in the exam, they can ask which of the following is the correct one. So, what I told you, if you are not, there is no 1, 1, 1 present. Otherwise, we could have done it easily. So, if nothing is there, what I told you, add them vertically or horizontally. Means row wise or column wise, just add them and see what do you get. So I'm going to perform one operation. C1 goes to C1 plus C2 plus C3, or R1 goes to R1 plus R2 plus R3. Last time we did R1 plus R2 plus R3. Let's do C1 plus C2 plus C3. Okay. So if I add them, one second. Yeah. So if I add them, first, so C1, this is C2, this is C3. So we have to add them. So 2x plus 2x plus x plus 4. So that becomes 5x plus 4. For this also, 2x plus 2x plus x plus 4, 5x plus 4. So here also it is coming 5x plus 4. Okay, rest is 2x, 2x, x plus 4, 2x, and 2x and x plus 4. Good thing is we can take now the 1 second. Yeah, we can take these three expressions are same, so we can take it common. So 5x plus 4 goes outside the determinant. 1 1 1, 2x 2x, x plus 4 2x 2x, x plus 4. And I think after this, now that you have solved these many determinants, you know what will be going, what is the thing that we are going to do. We are going to generate 0. Let's generate it. So if we are going to generate 0, what do we have to do? R2 goes to R2 minus R1, and third row also goes to R3 minus R1. Okay, so 1 2x 2x. Let's subtract 1 minus 1 0. X plus 4 minus 2x, you'll get minus x plus 4, or 4 minus x, your call. 2x minus 2x becomes 0. Okay, same for row 3. 1 minus 1 0, 2x minus 2x 0, x plus 4 minus 2x, again minus x plus 4, or 4 minus 2x. 5x plus 4 was already there. Now expand about this column. Okay, so very simple. 5x plus 4 into 1 into, leave the row, leave the column, and you have to solve the determinant of this. 4 minus x, 4 minus x. So basically 4 minus x whole square minus 0. Okay. So 5x plus 4. You can write 4 minus x whole square or x minus 4 whole square. Won't make much of a difference. Let's see what is written in the question. They've written 4 minus x. But we can write x minus 4 whole square also, because square will cancel the negative sign. Alright. Another kind of problem can be like this. Okay, for this question again we have to show this is a plus b plus c whole cube, but let's say the question say evaluate. The point is you have to generate something. First of all, 1 is not there, so your starting step is missing. Even if you can see there is no some sort of direct property applied. So what I told you, just add them row wise or column wise. So let's see. If I add them column wise like this, that will become 2a plus 2a 4a plus 5a minus b plus c. This will become, if I add this also, it will become 5b minus c minus a. This will become 5c minus a minus b. They are not making any sense, so not adding them column wise. Let's try row wise. Let's add them like this. So if you add 2b and 2c, this will become a plus b plus c. If you add them, these three elements, you will get b plus c plus a, which is a plus b plus c. Here also c plus a plus b. So adding them row wise is making sense. So let's go for this. R1 goes to R1 plus R2 plus R3. Okay, so it is becoming a plus b plus c, a plus b plus c, a plus b plus c. 2b, b minus c minus a, 2b, 2c, 2c, c minus a minus b. A plus b plus c is common. In the first row, I can take it outside. So I'm taking it outside, a plus b plus c. If I'm taking it outside, what is left inside? 1, 1, 1. Now the moment you get 1, 1, 1, I think pretty much you have the understanding what we are going to do. We're going to generate zeros. Okay, so generate 0 here, generate 0 here. Okay, let's see what happens. C2 goes to C2 minus C1. because we'll be using this one to get 0, and we'll be using this one to get here also 0, and C3 also goes to C3 minus C1. A plus B plus C, 1 0 0. This is 2B 2C. Okay, we are subtracting column 2 from column 1. Okay, column 1 from column 2 actually. So let's subtract 1 minus 1 0. 2C minus 2C is also 0. This one you have to do very carefully, so let's write it separately. B minus C minus A minus of 2B, that becomes minus B minus C minus A. If I take negative common, A plus B plus C, so basically it becomes minus of A plus B plus C. So don't do every single operation orally or mentally. If you are thinking something is complicated, take one step in the back. This one again, if we subtract it from 1 from 1, we get 0. 2B from 2B, we get 0. And this C minus A minus B minus 2C. So C minus A minus B minus 2C. So again you are getting minus C minus A minus B, which is, if we take negative common, A plus B plus C. So negative of A plus B plus C. And I think after that we already know what we have to do. Expand. Okay, so A plus B plus C determinant of that becomes 1 into negative negative become positive, so A plus B plus C whole square minus 0. Okay, so that becomes A plus B plus C whole cube effectively. A plus, because 0 will not have any effect, square with power 1, it will become cube. That's the final answer, and that's what we were supposed to prove also. All right, done. All right, okay. All right. I think that's it. Okay. Rest properties and solving equations. Now we have covered the properties of determinant. Next topic will be properties of adjoint, properties of transpose. I think transpose we already got. Properties of adjoint, properties of inverse. Okay, and how to solve system of equation, that will be covered in the upcoming class. So that's it for this class. Class for today is over. Okay, see you in the next class. Good day everyone. Bye.